This conference will now be recorded.
So, good morning, everyone, once again. This is the presentation for Automotive Measurement Solutions. And let me just give you a brief information about HIOKI for the ones who have not heard about that brand before or the ones who are dealing with HIOKI products for some time. I just want to give you briefly some figures. Today's session is about to give you the idea about what sort of solutions HIOKI is providing and also how you should be able to benefit from that. To do so, we have looked at 4 different areas. So basically power measurement and certain functions, how to make power measurement more accurate. Battery measurement systems, starting from production towards the final modules, over data logging, and also having quality assurance and reading out signals via CAN-FD. This will be shown in today's webinar, and to give you a quick understanding about HIOKI and where we are coming from. So this year we have the 85th anniversary, but we are very young in the European market. So we just recently set up 3 years ago a subsidiary which is looking after entire Europe. You will have the chance to get support, but also solutions across the world. So there are 8 subsidiaries across the world. So if you are a multinational company, obviously there is not only support coming from the Japanese market. To give you a little bit background about the way how HIOKI is working, their main drive why they are doing it is contribution to society. So basically whatever products they are developing is for having a greater good. At the end of the day, the product should be beneficial for supporting environmental approaches, but also to make someone's lives easier. And that at the end of the day is the reason why we are trying to come up with solutions which are helping you and supporting you. And that is also one of the main reasons why just 3 years ago, HIOKI Japan decided to come to the European market here as well, to get an understanding about what customers here in the European countries are in need of in order to fulfill their daily work with proper solutions behind. And one of the main areas where HIOKI is very strong in is about power measurement. So today I want to give you some ideas what sort of power measurements should be undertaken in order to produce but also develop, especially for the electrical or hybrid car areas, good solutions. So I think everyone is aware of that old formula which you have seen back in school or university, how you are achieving the reactive power, which is partly active power, but also apparent power. And at the end of the day, having too much of apparent power is not doing the deal. And at the end of the day, you want to have an understanding what is most efficient in your power electronics. So at the end of the day, this should only give you a metaphorical overview about power. But now coming into the real solution, you want to understand when you have electrical vehicles, or even if you look at renewable energy everywhere, it's the same situation. You want to improve your efficiency. And in order to do so, obviously, you would need to do it in a very accurate way. So here as an example, we have a power analyzer, the PW6001, and it's a 6-channel module which you can use as master slave. So ideally, you can set up to 12 channels, and this gives you the ability to check before and after inverter, for instance, what comes in, what goes out, in order to get an understanding about the real efficiency of your drive system. So with the combination of using such a power analyzer and also current sensors, you will receive the values in order to get an understanding how much loss you will have in your application. And this is also something you want to make visible as much as possible in order to get an understanding where is it happening. Is it because of somewhere happening in the harmonics? So you will be able to test the harmonics up to 1.5 megahertz, or where is it happening that efficiency is not improved in total. And that is one of the reasons why having a power analyzer, but also the right sensors, is something which gives you a good understanding about that. Now, as an example, when we look at the PW6001, you can very easily set up the power path, up to 4 in total, to have an understanding where losses are coming from and when they are happening. And at the end of the day, this is something you also want to visualize and you want to use as a reference for all future developments. So that's why we also offer you a software packages for free, which you will then be able to add to other products or other measurement results to get the full picture. So why is it happening that sometimes you will not get proper efficiency or you will not have most accurate results? Well, that's basically because of a mathematical error. And that error is happening especially when the power factor is closer to 0. So the closer it becomes to 0, the smaller the power factor is, the more mathematical error you will get. And that means you have already bought maybe a solution of a power analyzer which is very expensive, but you are not showing correctly the real efficiency of your power devices. But at the end of the day, when you want to sell a proper product or a high value product to customers, which is reliable with a lot of durability, obviously it is the best thing to have it in a very accurate way to improve your efficiency as much as possible. So HIOKI is not only producing power analyzers, but also the current sensors. And having both of the development in-house, that gives us an understanding about the characteristics of each current sensor. And that means we were developing in the past years current sensors and this function in the power analyzers to do a phase shift correction. So because of the frequency spectrum or bandwidth, the higher we are in the bandwidth, the more problems we will have because of capacitance and inductance, and that will lead to a deviation of the phase angle, and that means you will have a phase shift. In order to compensate that, and our analyzers are aware of the characteristics of each sensor, we have the function of phase shift correction, which can be switched on but also kept off in the power analyzer to do a correction. So when you look at the chart and around 10 kilohertz, we have a start of a shift, and you want to get that shift corrected. So at the end of the day, what's happening is we know the deviation, and our power analyzer will add that automatically to the measured result, and this will then lead to a more accurate result because of the addition of the miscalculation. To make that more visible, or to give you a showcase example, We were using two of our sensors, one time with the phase shift correction function off and one time with the phase shift correction turned on. And as you can see on the first chart, around 20 kilohertz, we already have or between 10 and 20 kilohertz, we already have the deviation. But what you want to achieve is a more constant and more accurate measurement result across the bandwidth. And that is one of the reasons why when you turn off that phase shift correction function in combination with the current sensors, where the power analyzers know the characteristics across the frequency bandwidth, you will be able to increase the performance of the measurement result up to 1 megahertz. And at the end of the day, that will then give you a better understanding of your power system. We also did some tests to get an understanding how it looks when you have it done with a conventional product and when you use it with phase shift correction. And what we could see that the frequency or the measured result are having a 0.5% difference in terms of efficiency. So as a statement, when you want to compare yourself, your product with another product, or you want to see what is actually having the best result, ideally you want to get your measurement done accurately to give also a claim that your development is having most efficiency in order to not only lose power, but also to make most out of that. So when we look at the power analyzer, in order to get accurate results, you also want to use the proper current sensors. And in that area, I want to give you a quick understanding when to use which sort of current sensor in order to get the most adequate measurement results. HIOKI is offering 14 different models, and ideally, to make it as easy as possible for you as a customer, you want also to have plug and play, because when you are creating products and you will have maintenance or service done by other companies or your peers, ideally they would only need to do this with in a very quick way, so that across departments, everyone is able to fulfill the measurement task. Obviously, the WLTP standard is also based on measurement on DC level, and that's why from the bandwidth, our sensors are DC to 4 megahertz, so that you are also able to have a good understanding from DC level up to very high harmonics level. And also, when we look now at the automotive industry, in which we have more and higher voltages happening at the moment, the rating up to 2000 amps is becoming more and more regular. And one of the main benefits is also that you would not need to have an external power supply. That will then be provided by the power analyzer itself in order to make the cabling and the wiring as quickly and as easy as possible. And now going a little bit into the technical differences, there is obviously as a first step the question, will I use current sensors or not? And we want to highly encourage you to get the measurement done with current sensors, because if you already invest in an expensive power analyzer to have a good understanding, obviously you want to have also a more accurate result and not a deviation. And this is obviously the case when you have a direct connection. So the direct connection is going via a shunt, which should be then included. And this is obviously also something where most people are not changing every year a shunt in order to compensate what happened because of heating inside the power analyzer. Because when you go directly onto the power analyzer, there will be heat generation, and that is then also causing a degradation, and that means you will have more inaccurate results. A second problem when you have a direct connection is that because of long wiring, you will have, from a physical point of view, already higher resistance in that, and that will also cause problems and external effects when you want to have proper measurement results displayed. That, on the other hand, is something you can prevent when you have a sensor in use. And our sensors are transformers. So we are picking up the voltage signal and converting that into current. And that also leads to less heat. That also leads to a better understanding about the characteristics. And ideally, will give you also a good understanding about the measurement itself. So we wanted to give you also a quick proof how a shunt resistor is behaving when you have direct input connected. And the direct input is also then causing heat, and this is then the problem of degradation, or in other words, it's thermal aging of the shunt resistor. And then when we want to talk about which current sensor to use, because we have already seen that using current sensors is bringing you better results, we want to either have the clamped sensor types on or closed loop sensor types. So depending on your application, is it a fixed bench or is it a more operational way of I want to check here now, or I want to change, or I want to measure at a different location, then obviously you need to decide whether clamps or closed loop sensors are the right choice for you. In terms of accuracy, closed loop sensors are more accurate because compared to the current clamps, you don't have the little space to clamp on. On the other hand, you have the downside that you need to cut cable first, or you need to do the wiring through the closed loop sensor before fixing the inverter, battery, or motor drive system. But one thing we want to definitely highlight is to not use any Rogowski coils, because the problem is the way of the setup. You will have more noise around that, and if you already have a high value measurement system and then you use Rogowski coils, that will just lead to a less improved accuracy. So at the end of the day, you lose what you gained with having a better power analyzer, and that is something we would not recommend to do. So basically, this is the area of power measurement and using and choosing the right sensors to do that. Another area where HIOKI wants to support is in order to also protect the people inside the car, because high voltage is always a risk, but also to make your developed products as durable as possible. So in the terms of battery measurement solutions, you will see that you can start at the very beginning of a production or manufacturing cycle, and to come up with cells, but also the modules, which are entirely checked from the quality point of view. HIOKI does start with the electrode sheets, in which we can see the resistance of that. And I want to highlight two areas in that presentation. So one is the area of tap welding, point 2, and as a next process step, it's about the cell testing or pack module testing. So for each step, you would need to select the right product to suit your needs, to get an understanding if your battery solution is as powerful as possible. And depending on if you are getting the products from, getting the batteries from suppliers, you might simply want to test it on quality, or if you are even developing the batteries in-house, you want to have the best understanding in order to increase reach, because at the end of the day, that's one of the main things nowadays customers are expecting, to have a longer distance to follow. So one aspect is the inspection of weld. And you can see, depending on the material you are using and also the thickness of that material, you might end up with higher resistance. And the higher resistance, because of the contacting, that is also one of the reasons or one cause of more heat production, which leads to more battery defects, but is also a waste of energy. So when you have already efficiency, or you want to improve efficiency between battery, inverter, motor, load, obviously you want also to have each part as ideal as possible, and that's why from a manufacturing point of view, the battery needs to be perfect, but also inverter needs to be perfect. The coils of the motor windings need to be perfect. So each part is playing a major role in order to have a combined, very efficient system. And this will then lead to a more improved product for the customer, which is then also deciding to, I don't want to have problems when I'm charging, discharging, or I don't want to have to get battery replacements every now and then. So when we now look at the inspection on a cell level, you want to create a battery pack, and for having a proper battery pack, you would need to select the right cells to identify which are working or which can be paired best. Compared to a lead acid battery, for lithium-ion batteries, you would need to do the measurement on across the frequency bandwidth, because the characteristics compared to a lead acid battery cannot be measured on fixed frequency points, but they would need to be done across the range, which means starting from 0.1 hertz up to 1 kilohertz. And when you do that via sweep function, that means you connect your cells, for instance, with our battery tester BT4560, you will gain cold plots. And those cold plots you can use, or you can put together with also software you can download for free on our homepage. And you can then compare the cold plots in order to find which are the most suitable pairs to put them together to get a pack. And once this has been done, you can also do checks on the battery cell. So if you have a golden sample, to say, okay, this ideal or this cell is ideal because this cold plot shows it's fitting all my necessities. You then can also compare in inspections, but also in production, if these cells are fitting your wishes, how this battery cell should be acting. Once this is assembled to a module or a pack, we are using then resistance meters also internal resistance ACIR method to test up to 1000 voltage if the battery pack is functioning properly. So it's kind of a stress test in order to see whether a pack is able to charge, discharge quickly enough. And this is also can be shown in a graph in terms of resistance, how it is changing depending on the levels on the ranks. So basically, the battery solutions should give you an understanding from the very beginning of the battery production towards the end, when you have the full pack, in order to get an understanding if that battery pack is still working properly or not. Another important aspect is you want to make data available to compare whatever you have developed or how the car is performing under test situation, or even in real situation. And you know as well that real situation is a completely different story to test situation. And for that reason, it is very crucial that you are also able to do the logging in an atmosphere where you don't need to connect the device always with cables, but you would also need to transfer wirelessly in order to get real measurement done, like in on streets. And for that reason, there is a new development. It's the LR8450, or the wireless module LR8450-01, which is then able to give you results across various parameters. So starting with data logging, what are the most relevant things you want to measure in that? It is most likely that you want to see how is the battery behaving in terms of voltage when you charge it, when you discharge it. Is there any change of temperature? Could that lead to any defects? What is happening when you are driving? Are any of the vibrations leading to damages inside the chassis or something like this? That is one of the reasons why we have now created 3 application examples, which should show you why having data logging across various parameters at the same time simultaneously will give you a much better understanding about the real performance of your vehicle. So the one example about battery cell is what I've briefly mentioned. You want to either use a voltage/temperature unit to see the behavior of the battery when there is, for instance, charging, discharging, or when you speed up and there is now a higher use of the battery. Or simply you want to also get more understanding about the efficiency of the charging itself. So you want to see the speed in a higher way of your voltage changes, and that's why, depending on which unit you will choose, you have either 1 millisecond sampling or you have 10 millisecond sampling. So depending on what sort of application you are looking at. And what is very important is that it should be as easy as possible for you to reduce the wiring efforts. And that's why having a wireless unit attached inside the chassis when you are producing or when you are creating your test device, you will then be able to do the measurement always when it's suitable to you and not when you need to wire it again. Another problem is the problem of vibration, or we use strain units for that. So what happened in the past, you would need to use an external bridge box, which is now part of our wireless unit. so that you will not need to add an external bridge box again. And then you simply need to attach the strain sticker onto what you want to measure. So if you will see any vibrations coming from the motor, coming from the axis, from the wheel, wherever you could see that this can harm your vehicle, you want to get those data and then transfer them onto your logging station. Or even if you are inside a car. I mean, the worst would be have high temperature in hot summer times. So at the end of the day, you want also to see where is heat coming from. Is there too much heat now in the trunk or wherever your battery is sitting? Is there any risk for cables, for other connectors, anything which could melt? Could that lead to defects of your electrical wiring? So whatever is happening in there, you want to have a proper understanding about the car and the temperature, and that is then in that example the reason for using temperature logging, and especially without attaching hundreds of cables to get that from several points. As an overview, the data logging system works with 5 direct plug-in models, but you can also use 5 wireless modules additionally, but only if you choose the LR8450-01 module before, because only this one has the wireless module included. And to make it more visible, we have up there the different units and the parameters which they are able to measure. So you see that there is a voltage unit, or there is a voltage circle 2 times. The first one is the high-speed voltage unit, which is able to sample with up to 1 milliseconds. The other one with 10 milliseconds is the combination between voltage temperature. So 120 channel for voltage or temperature with up to 10 millisamples for the sampling. If you have used LR8400 before, now with this unit is also possible to attach PT100, PT1000 sensors in order to get the temperature measurement done. And now I want to come back to the reason why is HIOKI producing products in power measurement, in battery area, but also in data logging. It's about to get the full picture, to give a solution for the entire system. And when you look, for instance, on that chart here, this is a this is our software called Genic One. You can download that for free, which is available when you use the URL below. And this will then be able to show you how the system is behaving from the power measurement, but also what you were logging, either connected directly or with wireless modules, to see is there maybe a loss in efficiency when there are certain vibrations coming up. Is there a certain temperature arising which could then also lead to less efficiency? So basically just current and voltage transformed to temperature. So this is something we want you to be able to bring into one picture and to have a full understanding. Why is your car, your vehicle behaving like this? And now I want to come to the last part, which is about non-contact CAN signal measurement. So for HIOKI, it's very important to make measurement as simple as possible, but also as safe as possible. And to do so, measuring contactless was already a claim for the current transformers. And we have used this function now also for CAN signal measurement. by using our SP7001 sensor, which reduces then also the wiring effort. So to give you a quick understanding, there are two ways of measuring it, CAN-FD, whereas CAN-FD is the faster method, and that is also then causing more waveform distortions. And what is the main benefit of that device? It is to make it as accessible as possible, because when you want to get to the cables to connect the probes, it is sometimes very hard to get there, but you want to do it as easy as possible. And also when you do troubleshooting, you want to be able to connect the CAN and the CAN analyzer properly without hurting and damaging any cables. So that is the reason why in this picture you can see how contactless measurement is improving your daily work. So compared to the conventional method, where you would need to cut cable insulation to get to the cable inside to capture all the signals, it's now simply something you would need to hook up around the insulation, tied it or screw it tight, and then you will have already a full proper signal. And you don't need to worry where you are capturing it from. You will get the signal always as good as possible. Now, the difference between CAN and CAN-FD is also leading to a problematic display of the waveform. So depending on how you are transferring the data, you might have more noise in that, and that leads to less accurate results of the waveform. And for that, we have used that together with our data acquisition system to display that in terms of a waveform. And what we can see here, when we have the contact method, so where you need to take off the insulation and make the signal visible, versus a non-contact sensor method, you can see that there is a much clearer picture of the signal, which then gives you a better understanding of if or what the CAN is communicating inside the vehicle. And how to make that then working for you if you have the non-contact probes. And that is happening if you either already use, and now it's a third party, it's called Vector. Either you already use a CAN interface to make CAN signals available to you. So having another CAN sensor attached to that CAN interface to make it then visible on your PC. Or if you want to make it visible on a data acquisition system in order to display various signals at the same time to see how they are in relationship to each other and how they are behaving. So we have done that as an example with our MR6000, which you can see on the right-hand side. That's the data acquisition system for recording functions, with more functions than a regular oscilloscope. And that gives you then the possibility to do also some analysis on the waveforms and also the timing. So this is something set up to give you an understanding. It's basically our MR6000, which is connected with the CAN interface. Whoever is owning a MR6000, you would need to upgrade the firmware up with the latest version 3.0. This then makes you able to also use the CAN function. All new items or new devices are already equipped with the latest firmware. when you then connect the recorder with the CAN interface and with the sensor, you can see there, as an example, 6 different waveforms or 6 different signals. And those signals is, for instance, how much are you turning the wheel? Are you braking? Are you accelerating? Do you have the handbrake on? All those signals you can read at the same time simultaneously, and also make available in terms of DBC files to your PC, so that you also have a understanding in the future or a comparison. That is also something you can, after recording the data, you can analyze at a later time. And this is then simply recorded by our SP7000. To sum up, this is another example of how we want to combine the various products of HIOKI to make a proper understanding for your devices. So now we are coming to the questions and answering section. Obviously, I was just giving you some highlights about what sort of portfolio is available, and we are very open and happy for any sorts of insight, feedback, how you are using our devices or other devices, what's important to you, to also get a European flavor into our products for your specific application, to make it also possible to newly develop technologies which are suiting you more than maybe they are currently doing, or if you have pain for something else. So please feel free to give me any questions via chat, and then I will trying to answer as much as possible to that. And in the meantime, if you don't have any questions now, you're also able to get back to me via mail, or you can also reach out to our partner Jakova. Here is mail address and contact information for phone. If you have any questions or you would need some demos in front of you. So it's also possible to use our products to test if it's suiting your application. At the end of the day, it is something where we want to learn if you have something which is not available at the moment.
Hi, Daniel.
Hi, Luca.
Hi, I can speak in Italian just to quick end this webinar. Buongiorno a tutti, grazie per aver partecipato a questo webinar. Se avete ulteriori domande o anche altri aspetti tecnici che volete poi approfondire anche successivamente, tutto il team Giacova è a vostra disposizione. Potete tranquillamente scrivere a Sales o contattarci direttamente. Se avete in questo momento altre domande da fare a Daniel, ai colleghi di HIOKI, tranquillamente potete riattivare voi il microfono oppure scrivere nella chat che vi risponderemo. Daniel had just checked that they want to reopen the microphone to answer if they have more questions, or else we can end this webinar. And thanks to all the participants.
Yes, so I have unmuted everyone. Whoever wants to unmute themselves to raise a question, please feel free. Otherwise, just get back to us afterwards. Okay, so to me it looks like that I will stop the recording now.